the nucleosynthesis extension to the standard model of particle physics for those who just have to have a laugh. By Edwin Campbell with a little help from an AI. Nucleosynthesis. The fiery, slightly tipsy process by which stars, those radiant, flaming cosmic crockpots, cook up the ingredients for everything from your grandma's antique silverware to the neurons firing in your brain as you read this sentence. Buckle up, dear reader, because we're plunging headfirst into the gloriously ludicrous smelting party at the heart of stars. This isn't your average physics lecture. This is celestial cuisine meets thermonuclear vaudeville. And yes, it's absolutely, irredeemably absurd. Oh yes. Absolutely. You want more bizarre? More hilarious? You want a description so gloriously deranged it makes Monty Python look like a tax seminar, and yet somehow still accurately explains stellar nucleosynthesis like a champagne-soaked physicist at a Renaissance fair? Strap in, friend. We're about to take a thermonuclear dive into the deepest, weirdest, scientifically accurate fever dream the universe has ever belched into existence. This is nucleosynthesis, stellar alchemy in a cosmic croissant oven. Imagine, if you will, the sundae. Not the warm, glowing ball you drew in kindergarten with a smiley face and sunglasses. No. This is a 13 billion trillion ton cosmic cauldron, boiling hydrogen like a deranged intergalactic soup chef with a PhD in plasma aerobics and absolutely no chill. This isn't a gentle simmer. This is atomic pro wrestling in a confined space, starring protons on fire, bludgeoning each other into friendship at 15 million degrees Kelvin while shouting things like "for science and glory." Let us enter the core. Cooking Act I, the proton-proton smackdown begins. Hydrogen atoms, aka protons and singles bars, are slamming into each other at absurd velocities because the core of the Sun is basically Manhattan during rush hour. But every pedestrian is a subatomic particle going 1000 km per second and all of them are trying to fuse. But here's the twist, protons hate each other. They're both positively charged. They're like two grumpy old men with the same opinion yelling at each other across a bingo table. So why do they fuse? Because, quantum tunneling. Yes, you heard me. These little scamps cheat the laws of physics. They don't jump the energy barrier. They quantum sneak through it like cat burglars made of fire. 1 second they're outside the energy wall, the next BOOP, inside, snuggling up, whispering sweet nuclear nothings. Eventually, one proton screams, "I can't take the pressure," and transforms into a neutron, emitting a positron, the electron's positively charged evil twin, and a neutrino, a particle so socially awkward it immediately leaves the party and never talks to anyone again. Boom! Now we have deuterium, which is hydrogen with a stylish new neutron hat. Act II, helium is born, possibly while screaming. The deuterium, that's proton and neutron, for those keeping score, hooks up with another lonely proton, and now we've got helium-3, not full helium yet, but close, like a croissant that's only 75% baked. Two helium-3s meet at a bar, both suspiciously glowing, and say, "You complete me," then fuse into helium-4 and eject two protons like unwanted wedding guests. This part is known as the proton-proton chain reaction, or, if you're feeling spicy, the subatomic conga line of creation. All of this releases energy, and lots of it mostly in the form of gamma rays, which are like photons on an espresso bender, vibrating so hard they could melt your soul and make your microwave cry. Dancer Act III, the energy's journey, a 100,000 year traffic jam. Now the energy has to get out of the sundae. Simple, right? Wrong. A single photon, born in the sun's core, begins its majestic journey to the surface. It's like a cosmic pinball bouncing, scattering, ricocheting off every plasma particle like it's trying to navigate a mosh pit full of rugby players in a fog machine. Every time it tries to go straight, boom! Another collision. On average, it takes 100,000 years to reach the surface. That means the sunlight warming your face right now was born before humans invented agriculture. You're being touched by prehistoric photon drama. Act 4, bigger stars, bigger drama, bigger boom. Now let's get weirder. Our sun is just hydrogen fusion light trademark. Big stars? They don't stop at helium. They turn into elemental Michelin star chefs, cooking up new atoms like Gordon Ramsay with a flamethrower. Here's the nuclear tasting menu. Helium carbon. Carbon oxygen. Oxygen neon. Neon magnesium. Magnesium silicon. Silicon iron. Each stage of fusion is a desperate, high-stakes juggling act as the star yells, more heat. More pressure. I need to fuse harder, until it starts fusing silicon into iron, and that's when it hits the wall. You see, iron is the party pooper of fusion. You can't get energy out of fusing it. It just sits there like a judgmental ex at a reunion, silently ending everything. The core collapses. The star says, well, this is awkward, and then. Collision symbol Act V, the supernova cosmic midlife crisis explosion. Boom. Supernova. This isn't just an explosion. This is a thermonuclear detonation so intense it briefly outshines entire galaxies. It's the universe's way of rage quitting. In that moment, atoms are smashed together with such violence that elements heavier than iron, gold, platinum, uranium, and all the fancy stuff humans use to build smartphones, bombs, and wedding rings are created and hurled across the cosmos like glitter from a vengeful drag queen with godlike powers. Stars don't go quietly into the night. They go fabulously. Milky Way, and now, you, the accidental stardust meatbag. Here's the punchline. You are made of this nonsense. Your teeth? Calcium forged in stellar fusion. Your blood? Iron built in a star's core. Your ability to comprehend this absurdity? Neurons firing using elements formed in an explosion so intense it could rip spacetime a new one. You are a living monument to a star that exploded billions of years ago, and the universe looked at your carbon-based form and said, yes. This meat popsicle shall ponder its own atomic ancestry. Dr. Too ludicrous? Definitely real. Stars are nuclear fusion machines powered by peer pressure, quantum cheating, and the strong nuclear force. They smush atoms together and make new ones, releasing absurd amounts of energy. Big stars make even heavier elements, then die in flamboyant thermonuclear meltdowns. That stardust becomes you. The universe is a chaotic flaming nonsense fireball, and we are its confused, sentient sparkles.